Presentation of switching concepts. I think we all know what a switch is and what a switch does, but this is just to give you a basic explanation of the functionality of a switch in a local area network. We know that networks are really important these days because everything is sent over the network. Not only normal data traffic, but all kinds of different traffic like IP, voice over IP, and video conferencing, and whatever it may be. So networks are important. We know that. The whole idea about the switches I have over here is, the core in a local area network. The switches are designed to switch traffic from one port where it comes in to a port where the data will be sent out. And there are different ways of doing that, and that is what I'm going to explain to you in this short video presentation. There are different types of switches as well. If you look at the overall designs, we have like these swarms which are fixed in the number of ports. When I buy this as a 24 port switch, and that's it. I cannot extend it in any way or scale it up or scale it down. This is a fixed configuration of the switch. If I were able to spend a little bit more money, I could buy a modular switch where I can just buy different modules and put them in after I have bought the switch so that I can scale it up and scale it down to whatever needs I have. So that is a modular switch. We could also have a stackable switch which has this special cable connected to the back side of them so that we can actually stack them. So that even though here I have 3 physical switches, then I can stack them so that they will actually work as one big switch instead of 3 different smaller switch. So these are, when we are going to buy a switch, this is what we can look at. If we look at how a switch functions, it's quite simple because the switch, in this case a layer 2 switch is what I'm talking to you about now, is a device that will look into the MAC addresses. And whenever you start sending something, the switch will see that, okay, now I receive data from this MAC address on port 1, for instance. Then it will know that behind port 1 we have this specific MAC address. So when you start sending data, the switch will start learning about the different MAC addresses that are connected to the different ports. And it will keep a table in and look into its MAC address table whenever traffic is received. And then it can, just switch it to the correct port. So it looks at the MAC address, and the MAC address table is stored in something called the Content Addressable Memory, or the CAM table. This is where we find the MAC addresses. And of course, it has to learn about them before it can switch to the correct MAC address. And it's also important to say that layer 2 switches will only look at the MAC address, will never look at the IP addresses. And whenever something comes into a specific MAC address and the switch look up into its MAC address table and do not find the MAC address in the table, it will flood them to all ports. So it will actually broadcast them out to all ports because it doesn't know where to send it. When we look at the way that it will, the switches are sending the data out, there are 2 different ways. The first one is called the store and forward, and the other one is called the cut through. The last one, the cut through, is the fastest way, and the store and forward will actually check that everything is okay before it is sent out. If we first look at the store and forward, we would see that if we look at a normal Ethernet packet like this, the store and forward will check the entire frame or the entire packet before it starts sending it out to the port it is supposed to be sent to. So it checks also the checksum in the end of the frame. And if something is wrong with the checksum, it will ignore the packet or delete it. So here we can say that we have an error check within the switch itself. And it buffers the entire frame before it starts sending it out. So this is the more, the more safe way of doing it, the store and forward. The easier way is the cut through, where you just read the MAC address and that's it, and then you start sending the packet immediately instead of receiving everything before you send it. And this is the way normal switches will work today, is like a cut through. You can normally change that in most Cisco switches. At least you can change the switching method if you have a preference for one of them. There is also one called fragment free, which will just make sure that the packet meets the minimum requirements of a Ethernet packet. Oops, yes. Another thing that's important when we talk about switches is that they will not create a broadcast domain, which means that a switch will automatically send out all different kinds of broadcast. If you send an IP broadcast out, it will be translated into a MAC broadcast and it will be sent out to all ports. So a switch do not limit a broadcast domain. We have to have a layer 3 device in to be able to limit the size of the broadcast domain. Yeah. So since the switches has a very important role in our local area networks, we need, of course, to make sure that the way that we design it and the way that we set it up and configure it will be the best for our network. And that is, of course, the way that we set up whether we want the one on the other switching methods. Also, the port number, the number of ports, the speed of the ports. If we have a switch or a server connected, we might want to have a faster port. Sorry, on that on the port where we have the server connected to. Whereas normal workstations can be on a 100 megabit and we can have a gigabit connection to the servers. So we need to design so that we don't get bottlenecks in our networks. Yep, and that was it about the basic switching concepts.